Throughout history, scientists have strived to understand the origin of the universe. The most widely accepted explanation has been the Big Bang theory, a hypothesis that many reference when discussing the universe's beginning. This theory, supported by decades of research and countless studies, has long been seen as the most plausible explanation of how the universe came to be. However, in today's rapidly advancing scientific landscape, new technology and discoveries challenge our previous assumptions. Neil deGrasse Tyson has become a key figure in exploring this evolving universe of science. Recently, the James Webb Space Telescope has made groundbreaking discoveries that could force us to reconsider the Big Bang hypothesis. The telescope has identified 750 new galaxies, and these galaxies are not what scientists expected. This has led to a reconsideration of previous theories about the universe's formation. The James Webb Space Telescope was designed to help us understand how galaxies formed. It's no surprise, then, that its discoveries are causing a stir in the scientific community. According to the Big Bang theory, the universe began approximately 13.7 billion years ago following a massive cosmic event, like the dramatic story of the universe's birth. However, the images from the Webb telescope challenge this narrative. The images show galaxies that are smaller, smoother, and older than the theory predicts. According to the Big Bang theory, as the universe expands, galaxies should appear larger the farther away they are. Yet, the galaxies discovered by the Webb telescope defy this expectation. Additionally, the Big Bang theory suggests that, at the universe's inception, all matter was compressed into a tiny superdense point called a singularity. This singularity was incredibly hot, hotter than anything we can measure or recreate. The concept of this singularity comes from Einstein's theory of general relativity, which describes the physical laws that govern the universe. For years, scientists have maintained that the Big Bang theory was the best explanation for the universe's origins. However, these new images from the Webb telescope are causing researchers to question that assumption. The newly discovered galaxies don't fit the predictions made by the theory. The current understanding of the universe, based on the idea of the singularity and the subsequent cosmic expansion, is being challenged. According to the Big Bang theory, all the universe's energy originated from a very hot and dense point, a singularity, acting as the starting point for everything in the cosmos. Following this singularity, the universe began to expand and evolve over approximately 13.7 billion years, eventually leading to the universe as we know it today. This expansion started with a rapid burst, referred to as cosmic inflation, where the universe grew at a pace faster than the speed of light. It was as though the very fabric of space itself was expanding, with everything within it stretching along with it. Cosmic inflation helped shape the universe by making it more uniform and setting the stage for the formation of galaxies, stars, and other massive structures. The expansion slowed over time but continued, a phenomenon known as cosmic expansion. Evidence of this expansion has been observed through various means, such as the redshift of light from distant galaxies, which shows how the universe is continuing to expand. Now we come to the stunning images captured by the James Webb Space Telescope. These images show multiple galaxies in a single frame, and while they are breathtaking to the general public, they are proving to be surprising for scientists. The galaxies are much older than anticipated, which challenges our understanding of how galaxies form and evolve. The Big Bang theory had made certain predictions about the number of galaxies and how they should be distributed. Yet the Webb telescope's images show a far greater number of galaxies than expected. This has led scientists to question whether the theory's predictions are accurate. Some researchers are even starting to worry, as the discoveries are so far removed from what they anticipated. One of the most striking aspects of these newly discovered galaxies is their smoothness, which contradicts the Big Bang theory's expectations. According to the theory, galaxies should show irregularities and variations in their structures as a result of how they formed and developed. Yet the Webb images show galaxies that are unusually smooth, without the expected complexity and roughness that should have emerged during the early universe's expansion. After the Big Bang, all matter in the universe was packed into an infinitesimal space. As the universe expanded and cooled, changes took place, with particles like protons, neutrons, and electrons interacting with light and energy. These interactions played a critical role in the formation of matter in the universe. In the minutes following the Big Bang, a process known as nucleosynthesis occurred, resulting in the formation of light elements such as hydrogen and helium. These elements laid the foundation for the development of stars, galaxies, and more complex structures as cosmic history unfolded. The Big Bang theory predicted that galaxies would be chaotic and irregular due to various factors. However, the images from the Webb Space Telescope tell a different story. Instead of the turbulent and disordered galaxies that the theory would suggest, the telescope shows galaxies with smooth disks and orderly spiral shapes, resembling the galaxies seen in the present-day universe. This astonishing discovery challenges the idea that chaos is a natural part of galaxy formation. In summary, the recent findings from the James Webb Space Telescope are reshaping our understanding of the universe's beginnings. The galaxies discovered don't align with the predictions of the Big Bang theory, raising important questions about how galaxies formed and developed. These discoveries suggest that our understanding of cosmic history may need to be revised as new, unexpected insights emerge from the frontier of astronomical research. Assuming there are few or no significant impacts occurring in the proposed universes based on the hypothesis of the universe's origins, it seems unlikely that smaller worlds could grow into much larger ones. Additionally, the optical illusion predicted by the expanding universe theory, where objects appear smaller with increasing distance due to expansion, does not seem to hold in certain observations. Astronomers have noticed a distinct pattern where galaxies tend to cluster into large groups, forming complex structures across the universe. This large-scale structure aligns with the predictions of the Big Bang theory, which suggests that the universe began in an extremely hot and dense state, and has been expanding and cooling ever since. As the universe expanded, gravity played a crucial role in shaping how matter was distributed, leading to the formation of galaxies. The gravitational effects predicted by the Big Bang theory are consistent with what we observe today. Gravity organizing matter, resulting in the clustering of galaxies and the creation of interconnected filamentary structures known as the cosmic web. The existence of these galaxy clusters and the cosmic web strongly supports the Big Bang theory. The way galaxies are distributed across the universe aligns with the gravitational effects expected from the initial dense and expanding state proposed by this theory. These factors, galaxy clustering, the cosmic web structure, and the distribution of galaxy groups, provide solid evidence that the universe evolved from an extremely dense state and has been expanding for billions of years. Now, let's consider the size of the galaxies observed by the James Webb Space Telescope. These images challenge some of our previous understanding of the universe's origins. According to the theory, smaller galaxies should grow through impacts and mergers with other galaxies. However, observations from the James Webb Space Telescope seem to contradict this idea. If galaxies were colliding and merging as expected, we should see evidence of these impacts or their effects on nearby galaxies. But the images show something different. So, does this mean the Big Bang theory is just a hypothesis with no supporting evidence? No, it is actually backed by undeniable evidence, including observations of the redshift of light from distant galaxies, which supports the expanding universe theory. The redshift indicates galaxies are moving away from each other, consistent with the expected expansion. The abundance of light elements like hydrogen and helium throughout the universe also supports the Big Bang theory, as these elements were predicted to form in the early stages of the universe. Moreover, the large-scale distribution of galaxies revealed through astronomical surveys matches the patterns predicted by the Big Bang theory. One of the most significant pieces of evidence supporting the Big Bang is the discovery of the cosmic microwave background, CMB. The CMB is faint radiation that fills the entire universe and represents the afterglow of the Big Bang. First detected in 1965, the CMB closely aligns with predictions made by the Big Bang theory. The observed properties of the CMB, including its uniformity and temperature distribution, strongly support the idea that the universe was once in an incredibly hot and dense state before expanding. The discovery of the cosmic microwave background has been a crucial piece of evidence that provides us with a glimpse into the early moments of the universe. It acts as an echo of the early stages following the Big Bang and has played a vital role in establishing the Big Bang theory as our best explanation for the origins of the universe. However, recent discoveries have challenged some aspects of the theory. The presence of galaxies that seem to predate the Big Bang contradicts the central premise of the theory, suggesting that the Big Bang may not have occurred exactly as originally thought. This raises questions about whether everything in the universe truly began from this event. Proponents of the Big Bang theory had anticipated that as the James Webb Space Telescope observed deeper into space and further back in time, the number of distinct galaxies would decrease, eventually leading to a cosmic dark age. However, recent research shows that even a few 100 million years after the hypothesized Big Bang, galaxies as large as our Milky Way were common. The images from the James Webb Space Telescope reveal a much larger number of massive galaxies at redshifts greater than 10 than scientists had expected, challenging the validity of the Big Bang theory. Furthermore, the Big Bang theory is associated with several incorrect predictions in the current body of scientific literature, with only one accurate prediction regarding the abundance of deuterium, a form of hydrogen. Some of the incorrect predictions include estimates of helium abundance, which were off by a factor of 2, and predictions about the amount of lithium, which were off by a factor of 20. The theory also fails to explain other anomalies, such as the expected optical illusion where objects should appear smaller with increasing distance. These inconsistencies raise concerns about the accuracy of the Big Bang theory, prompting further investigation into the origins of the universe. Observed in the infrared range allow cosmologists to estimate the ages of stars within these galaxies. Some of these galaxies appear to have stellar populations over 1 billion years old, challenging the traditional view that nothing could have formed before the Big Bang. Despite these significant discrepancies, the potential failure of the Big Bang theory has not received widespread attention in mainstream media. This lack of attention can be attributed to what's known as the emperor's new clothes effect, where questioning the theory often leads to criticism or accusations of ignorance, deterring further investigation into alternative models. One such alternative is the cyclic universe model, which could explain some of the newly discovered galaxies. These galaxies might be part of a cycle we are currently observing. However, it's important to note that these alternative hypotheses come with their own complexities and challenges. The academic community continues to explore and debate these ideas, as ongoing research and open discussion are essential for advancing our understanding of the universe. The tools we use to explore the cosmos are becoming increasingly sophisticated. The James Webb Space Telescope, JWST, with its advanced capabilities, offers a new perspective, shedding light on aspects of universal formation and evolution previously hidden from view. One of the key advancements of JWST is its ability to observe galaxies at different stages of development and at various moments in their life cycles, providing a more detailed view of their evolution. Recent observations suggest that the early universe may have been more complex than previously thought. For example, JWST data shows that some of the newly discovered galaxies formed much earlier than expected, challenging our understanding of cosmic timelines. These findings push the boundaries of current models and force scientists to consider alternative explanations. Another intriguing possibility is the presence of primordial black holes, hypothetical objects that could have formed in the early universe. If these black holes exist, they could significantly influence the formation and evolution of galaxies, introducing new variables into our understanding of cosmic development. JWST's high resolution also enables scientists to study star and planetary system formation in unprecedented detail. By examining the light from distant stars and the surrounding gas and dust, researchers can gain insights into the processes that govern star formation and the emergence of planetary systems. This information is crucial for understanding how life-sustaining conditions could arise in other parts of the universe over the course of time. Throughout history, humanity has made concerted efforts to understand the origins of the universe. The most widely accepted explanation has been the Big Bang theory, which has garnered significant support from numerous studies and the dedicated work of thousands of scientists, providing a wealth of evidence about the universe's beginnings. However, recent discoveries, particularly those made by JWST, have introduced new ideas and perspectives that challenge long-held beliefs. Neil deGrasse Tyson has been a prominent voice in this evolving field, contributing to the ongoing discussion. One particularly exciting development is the discovery of 750 new galaxies by the JWST, which differ significantly from previous expectations. These findings are prompting scientists to reconsider what they thought they knew about the universe. The design of the telescope aims to enhance our understanding of how galaxies formed, and its discoveries are reshaping our views of cosmic evolution. Traditionally, the Big Bang Theory has provided the best explanation for the universe's origins. According to this theory, about 13.7 billion years ago, the universe emerged from a mysterious event, akin to a dramatic birth. However, the images captured by JWST challenge this concept. The newly discovered galaxies are smaller, smoother, and older than predicted, raising new questions. The Big Bang Theory posits that, as the universe expands, galaxies should appear larger the farther away they are. Yet, the newly discovered galaxies contradict this rule, leading to further inquiries. The theory also asserts that, at the universe's inception, all matter was compressed into an extraordinarily dense point, known as a singularity. This singularity was incredibly hot, much hotter than any conditions we can currently replicate or measure. The concept of the singularity is grounded in Einstein's theory of general relativity, which describes how all matter in the universe was once packed into an incredibly small, dense space, resulting in enormous amounts of mass and energy concentrated in a tiny volume. In simpler terms, scientists have long argued that the Big Bang Theory explains how the universe began. However, the new data from JWST requires a reassessment of this idea. The characteristics of the newly discovered galaxies do not align with the predictions of the theory, suggesting that our understanding of the early universe may not be as definitive as previously thought. It is currently accepted that all the energy in the universe originated from this hot, dense singularity. This singularity serves as the foundation for everything we observe today. Following this initial state, the universe began to expand and evolve over billions of years, gradually becoming what it is now. This expansion is believed to have started with an event known as cosmic inflation, during which the universe expanded at an astonishing rate, even faster than the speed of light. It was as if the very fabric of space itself was stretching, with everything within it expanding alongside it.